Hello students, welcome to Educate. In this video, we will discuss the chapters aldehyde, ketone and carboxylic acid. Before the introduction of that one, that is what is aldehyde, ketone and carboxylic acid, firstly you should know about acyclic carbon atom. So let's see here. This carbon, when one oxygen will be directly bonded to the carbon, then that will be called acyclic carbon. This one is called acyclic carbon. It will be called acyclic carbon. When to this acyclic carbon, when one side there will be hydrogen and one side alkyl group, then that will be called aldehyde. In aldehyde, to one side there will be alkyl group and to the other side there will be hydrogen group, hydrogen bonded. So when there will be an alkyl group and a hydrogen bonded to the carbon, acyclic carbon, then the compound will be called aldehyde. In the same way, when both sides there will be alkyl group, then that will be called ketone. In aldehyde, one side alkyl group and other side hydrogen. In ketone, both side alkyl group. If there will be one side alkyl group and other side OH, then that will be called carboxylic acid. In carboxylic acid, one side there will be alkyl group and other side OH. And if there will be alkyl group one side and other side NH2, then that will be called amide. The difference in amide and amine is that in case of amine, the NH2 group, that will be this amino group, that will be bonded directly to the alkyl group. So that will be called amine. In case of amine, the amino group will be directly bonded to the alkyl group. And when the NH2 group will be bonded to the acyclic carbon, and that will be bonded to the alkyl group, that will be called amide. Okay, now let's see. If to the acyclic carbon atom, one side alkyl group and other side alkoxy group, that means alkoxy group means oxygen bonded to the alkyl group, then that will be called ester. To the acyclic carbon atom, when one side alkyl group and other side halogen, then that will be called acyl halide. If the two acyclic group like this one will be bonded to the oxygen here like this one, so it will be called acid anhydride. Acid, because there is this compound will form by the removal of water molecule by dehydration of carboxylic acid. So that's why this compound will be called acid anhydride. Okay, that was about the introduction. What is aldehyde, what is ketone, carboxylic acid, acyl halide, amide. Ester, what is anhydride? That is here. There is some compounds. This one here, some compounds which is used in day-to-day life, like vanillin. You know the ice cream vanilla, you have eaten a number of times. That is here in that one. The compound is vanillin. That is here the aldehyde groups, aldehyde compound are highly pleasant smell that has. Okay, so that's why, like vanilla, you have eaten the ice cream vanilla and you like the ice cream vanilla due to its pleasant smell. I hope so. So that is here vanillin, salicylaldehyde. What is that? Cinnamaldehyde. What is that? So that is here. This is the common name. Okay, IPAC name will be different, and I hope you could write the IPAC name of this compound very easily. Okay, now let's see nomenclature. So in nomenclature, first of all, let's see there are some compounds for which common names are also used, because these compounds are abundant in our day-to-day life. So common names has been also provided for these compounds. So one here is here ethanol, that is called acetaldehyde. Same benzaldehyde here, beta bromobutyraldehyde, that is the common name. These one are used in our day-to-day life. Like here acetone, same here, this compound that is called both side alkyl group. When both side alkyl group attached to the acylic carbon, that will be called acetone. IPAC name propanone, I hope you know already. Here this is called acetophenone. When one side there will be phenyl group and other side there will be methyl group, then that will be called acetophenone. Propanone, same here, that is commonly called propiophenol. Guys, about this one, this common name, keep in your mind. Propiophenone it is. Okay, like here acetophenone, here is propane attached here, so that's why propiophenone. And same both side benzene, so that is called benzophenone. Okay, that was about the common name, and common name is based on the day-to-day life. That means what they are used in our day-to-day life. So common name has been provided. So these are the common name. Now in these compounds here, there are few compounds for which you should also consider about the common name. Now here, this is of 2 carbon, so that's why ethanol. Now how to write the IPAC name? Here this aldehyde group, so that will must include in the main chain. And here is also functional group, so you will have to include in the main chain. So then after you do the numbering here, during the nomenclature of these compounds, you will have to give lowest position to this aldehyde group. So 1 here, and the carbon atom of the aldehyde group will be also counted. That is 1, 2, 3, 4, 5, 6, 7. That means main chain is of 7 carbon. In this compound, main chain is of 7 carbon, and name of the compound will be based on the functional group aldehyde, and the suffix used for aldehyde is al, al. Keep in the mind about the alcohol, we use the suffix ol, ol, and in case of aldehyde we use the suffix al, al. Okay, so this one is the numbering. Then after consider about the substituent. This is methyl, this is bromine. So consider about the alphabetical order. So that will be bromine comes first, so that will be at 4th position. So that's why we write 4 bromo. And at 3rd position there is methyl, so that's why 3 methyl. And this compound is of 7 carbon chain, and aldehyde is the main functional group in this compound. So that's why we will write heptanol. Guys, here no need to write 1 al, because whenever aldehyde will be the main functional group, that is most senior functional group. So when in the compound there be aldehyde be the most senior functional group, then name of the compound will be based on the functional group aldehyde. So their position will be always 1, because you will have to count the carbon atom of the functional group also. So keep in the mind during the writing the IPAC name I am telling. When you will have to write the IPAC name, then you will have to count the carbon of the functional group. That is acylic carbon atom, you will have to count. So that is here. So that is the IPAC name of this compound. Now third one is here. So what is here? Third one. This is about the ketone. So ketone here. So that will get first position, then second and third. So at third position there is methyl, and it is cyclopentanone. Both sides there is carbon atom. This acylic carbon is bonded to the carbon atom from both the sides. Here the acylic carbon is bonded to the carbon atom from both the sides. So that's why it is ketone. And here also you will have to write the first position to this acylic carbon atom, and then after you will have to give the lower position to the methyl group. That means where you comes right clockwise or anti-clockwise, that you will have to decide that methyl group will acquire the lowest position by considering in which direction, that is clockwise or anti-clockwise. So here methyl group will get the lowest position when you will do the numbering in clockwise direction. So that's the first carbon, second and third. At the third position there is methyl. So we will write 3-methyl. That's why I had written 3-methyl, and it is cyclopentane. So that's why cyclopentanone. Now when you watch out here this hexane, so this one how you will include in the main chain? That cannot be included in the main chain. So how to write? For this one we write carbonaldehyde. So here we will not use the al, here we will use carbonaldehyde. That will indicate that the carbon of the aldehyde group has not been counted. When you will write the carbonaldehyde, that mean the functional group CHO has not been counted in the main chain. So this one here, so this will be the first position carbon atom, no substituent here. So simple here, this is cyclohexane, and here CHO is carbonaldehyde. So that's why cyclohexane carbonaldehyde. Okay, E will written here because in case of carbonaldehyde, the first letter, that is C, is not alphabet. No, sorry, is not vowel. And I have told you, and just in the general way, just consider that if the first letter of the functional group will be vowel, then you will have to replace E, and when not, then E will retain. So that is here. That's why the name of this compound is cyclohexane carbonaldehyde. Now let's see about this carbon, this molecule. So here this is the functional group, so that will get first position, and then after. Now here is in this case main chain is of 5 carbon, so that's why pent, and at second position there is unsaturation, so that's why enal we have written. Okay. Now watch out this compound. A number of times I have told you that when the open chain will contain the functional group, then the name of the compound will be based on the open chain, and the cyclic group will consider as substituent. So here this is a cyclic group, this one. So you will have to do numbering from here. Number will start from here, 1, 2, 3, this one, because the open chain is containing the functional group. That's why the cyclic group will consider as substituent, and the name of the substituent benzene is phenyl, and its position is first. So that's why written 1-phenyl propane 1-one, because ketonic group is at first position. That's why written propane 1-one. Okay guys. Now watch out this compound. In this compound there is aldehydic group and ketonic group both. In this compound there is aldehydic group as well as the ketonic group. So then we will have to consider about the seniority. So the functional group which will be most senior, the name of the compound will be based on that. That means the name of the compound will be based on the most senior functional group. Always, whenever there will be more than one functional group in the compound, then name of the compound will be based on the most senior functional group. Then after, the other functional group will consider as substituent, and we will have to write the name of the substituent firstly according to their alphabetical order, and then after name of the compound based on the most senior functional group. So let's see here. As you know, among aldehyde and ketone, aldehyde is more senior than ketone. So that's why name of the compound will be based on the functional group aldehyde, and the functional group ketone will consider as substituent. So how to write that name of the compound? So this is aldehyde, so that will get first position, 2, 3, 4, 5. This one. So at this one here we will consider as substituent. So that's why 3-oxopentanal, or that can be also write 3-ketopentanal. The suffix oxo is prevalent these days for ketonic group. That means these days the name oxo are used on the place of keto. Today the word keto is not prevalent. So these days here, so that's why the name of the compound is 3-oxopentanal. Now watch out this compound. Here is only one functional group, that is ketonic group. So you will have to include this carbon in the main chain. You will have to select that longest carbon chain which will contain the functional group ketonic group. So here that is firstly 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, or 1, 2, or 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. So in this direction you go, you will get same number of carbon atom. And what is here? There is no substituent. If you will go consider this one, so here will be methyl, here will be methyl, the substituent. If you will count this one, then this will be the substituent and this methyl will be the substituent. If you will count this one, then this methyl will be the substituent. So in any direction you go, you will get same number of carbon atom in the main chain and same that is methyl group, same substituent, and at the same position. When you do the summation also, you will get same. If you write the IPAC name here, that means do the numbering and then after sum them. Whenever during the nomenclature, the lowest position will get fail, then we will try for the lowest sum rule. And if the lowest sum rule will also fail, then we will consider about the alphabetical order. So here I am writing firstly, whenever, that will be helpful for you for the main examination and for the NEET examination also. But if frankly speaking, for the 12th board examination, question will not ask of that level. So usually in the 12th board examination, questions usually asked in which there will be one functional group only, and in case of only aldehyde and ketone, that's containing two functional group. That means that chances is also less. So this concept which I am giving you, that will be helpful for you for the IIT main examination and for the NEET examination. Yes, that will have some relevancy for the CUET examination also, because the level of questions for the CUET is lower than that of IIT main or from NEET examination. So firstly, whenever you have to confusion from which direction you have to do the numbering, then first of all you will have to use lowest locant rule. If that rule will fail, if lowest locant rule will fail, then you will have to apply lowest sum rule. And if that lowest sum rule will also get failed, then you will have to consider about alphabetical order. Okay, so now let's see which compound we are doing. This compound. Okay, so that will be 1 2 3 4 5. From any direction you will take. That means you may verify that you select the different chain which I am selecting here, and then after write the IPAC name. You will realize that the IPAC name which you will write, that will be same as I will write here. So here in any direction you can do the numbering. So this is here methyl, this is methyl. So methyl is at second position and at third position. So that's why written 2,4-dimethyl. In the compound there is 2 methyl, in which one methyl is at second position and another methyl is at fourth position. That's why it has been written 2,4-dimethyl. And main chain is of 5 carbon, so that's why pentane. E has been replaced and written 3-on. Guys, also keep in the mind, if there will be 2 ketonic group, then E will written there. So we will write there pentane, E will written, and then after what their position, their di-on. Okay, now let's see here. In this compound, here CHO is outside the ring, so that cannot be counted. So that's why we will use the word carbaldehyde. Okay, so firstly write the IPAC name here. So this carbon, because there is another substituent also here. Substituent means here functional group, it will act as substituent, this NO2 group. So you will have to give position to this NO2 and the position of carbaldehyde. So the carbaldehyde is more senior than NO2, and for the aldehyde we use the suffix, and for nitro group we use the prefix. So obviously NO2 is too much junior than that of carbaldehyde. So the carbon atom to which the CHO is bonded, that will get first position, and then after you will have to do numbering in clockwise or in anti-clockwise in such a way that the other functional group or any substituent, that will get lowest position. So here it will be either you do in clockwise direction, when you do the numbering in clockwise direction, then NO2 getting fourth position, and when you do numbering in the anti-clockwise direction, when you will do numbering in anti-clockwise direction, then also the NO2 will get fourth position. So from any direction you can do the numbering. So it is at fourth position, there is nitro group, and then after it's benzene and carbaldehyde. That's why written 4-nitrobenzene carbaldehyde. Now when benzene attached to the carbon, that means when the CHO bonded to the benzene, nowadays it has been adopted by the IUPAC, that its name is benzaldehyde. The name benzaldehyde has been adopted by IUPAC system. So that's why we can also write 4-nitrobenzaldehyde. Okay, clear? Now let's see another. Now in this case, here the CHO, when you will count this carbon here like this, then you cannot count this one. But their seniority is same. So how it would be that you include some carbon of the some acylic carbon and don't include the other acylic carbon. So either you include all of them or don't include any one of them. So since here seniority is the same, that's why we cannot leave this acylic carbon atom. So this acylic carbon, this functional group, this functional group, and this functional group, all these functional group will not be included in the main chain, since here seniority is same, and by counting the 2 carbon, other carbon will leave. So that's why we will not count any one of them in the main chain. We will not include any one of them in the main chain. So how to write that? Then after, so now this one here, so I count this carbon. Okay, so 1 2 3. When you write at first position there will be CHO group, at third position CHO group, and at second position CHO group. And if you will do numbering from left to right, then also at first position there will be CHO group, second position CHO group, and third position CHO group. You will have to do numbering in such a way that this CHO also will consider acquire the lowest position. This CHO should also acquire the lowest position. So how's that? In this compound, that is not. There is from left hand side or from right hand side. You do the numbering. The CHO group will get same position, but in the compound in which there will be CHO group, third, that means third or fourth or whatever be the CHO group, then you will have to do numbering in such a way that the second CHO group will acquire lowest position. So in this compound, doesn't matter here, you do the numbering from left hand side or from right hand side, doesn't matter. So that's why this one I have from any direction you can do numbering. So this is carbonaldehyde, this is carbonaldehyde, this is carbonaldehyde. Because you have not included the CHO in the main chain, that's why you will have to write the suffix carbonaldehyde for CHO. So carbonaldehyde is at first position, second position, and third position. So we will write propane. So it is tricarbonaldehyde, and of tricarbonaldehyde when we write, then here also there is a consonant, not the vowel of the alphabet. Of the alphabet, we will get the consonant, that is tricarbonaldehyde, first letter of the word tricarbonaldehyde. That's why here E will retain. So that's why propane, in propane, E has been retained. So that's why written propane 1, 2, 3 tricarbonaldehyde. Okay, this one here written note. So you have to keep in the mind here. You will have to take this concept seriously. Now let's see the writing the name of these compound. Okay, and this compound which are we utilizes in our day-to-day life. That's why the common name has been also provided and IPAC name also. So common name is based on our day-to-day utility, that is which we uses in our day-to-day life, and the common name particularly is based on the Latin word. Like we tell formic acid because red ant called in the Latin as formica, and the methanoic acid released by the red ant when you touch in any red ant that's hit you by their sting, and during their hitting that secretes, the red ant secretes the methanoic acid, and that's why due to that acidic character you feel burning sensation. So here same, usually the common name of the compound is based on the Latin word. Okay, so let's see here CHO, that's called formaldehyde, common name here. Same here you can take, if there will be COOH, so that will be called formic acid, formic. Okay, and only one carbonate there is, that's why methanol. Now 2 carbon, that's why I call ethanol, and that will call acetaldehyde. In this compound here, what has happened? Structure is like this: 2 methyl group is bonded to this CH. So to this CH here, 2 methyl group bonded, and then after is CHO. So how to write the IPAC name here? So total number of carbon atom here is 4. In case of common name, how to write? Total number of carbon is 4, but that is not butyl, isobutyl it is not. So that's why written isobutyraldehyde, raldehyde here. Okay, isobutyraldehyde it is written. So of here L has been replaced and raldehyde will be, and IPAC name here. So it will get first position, second and third. So 3 methyl propanol. So that's why, 2 methyl propanol. So 2 methyl propanol, that's why written. Now in this compound here, for the IPAC nomenclature, here through this carbon here, when we write the common name, then watch out here, this carbon will get first position, and in that one we will call, this one is alpha carbon, this is beta carbon, and this is gamma carbon. So writing the common name, you have to write here about the alpha, beta, gamma. So here is the substituent is at gamma carbon here. At the gamma carbon, the methyl group is there. So that's why written gamma methyl. It is cyclohexane. So cyclohexane carbonaldehyde. Common name is that. And how to write an IPAC name? During IPAC name, we write the first position. We give first position to the carbon atom of cyclic group, which is bonded to the functional group. So that's why this CHO is bonded to this carbon. So this carbon will get first position. Here second position, here third position. So at third position there is a methyl group. So that's why we write 3-methyl cyclohexane carbonaldehyde. Common name will be gamma methyl cyclohexane carbonaldehyde, and IPAC name will be 3-methyl cyclohexane carbonaldehyde. Okay, why carbonaldehyde? Think. Recall that what I have taught you. Okay. Now let's see about this compound. So firstly, you will have to draw the structure of this compound. Then you will feel easy. If you will practice a lot, then you could write this compound fastly, as I did, as I could. But in the beginning, you will have to, if you are not confident, then you firstly draw the structure and then after write the IPAC name. So let's see about this compound here. So here it is CH3, here CH and OCH3. That means it's a methoxy group attached, not the ketone. Maybe someone think that it's okay, confused that double bond or not. So whenever you have the confusion, then consider about the tetravalency of the carbon. You will have to draw the structure by considering the tetravalency of the carbon. So methoxy group attached here, OCH3 here. So that is methoxy group attached, and then after C double bond OH or CHO, whatever you would like to write. Then after here, how to write? So this will be considered as substituent. That means main name of the compound will be based on that. Main name of the compound will be based on this chain, and this methoxy group will consider as substituent. So what, as we did, so first position to this carbon, second and third here. So methoxy group is at second position. So that's why we write 2-methoxy. And here 1, 2, 3. So propanol, 2-methoxy propanol, that's why here. Okay. Now, how to write the IPAC common name? So it is, this functional group is attached to this carbon here. So this carbon is alpha. During writing the common name, whenever you will have to write the common name, then the functional group bonded to which carbon? That will be called alpha carbon. And this one, and adjacent to that carbon will be called beta carbon. So functional group is CHO. It is bonded here to this carbon. So this carbon is alpha, and this carbon is beta, as well as this carbon is beta. This is not beta carbon. This carbon is not beta, because here CH3 is bonded to the oxygen, and that oxygen is bonded to the main chain. So that's why this one is beta carbon. So here methoxy group is at alpha carbon. So that's why we write alpha methoxy propanol. So here, okay, aldehyde here it is. Okay, so that's why propionaldehyde. That's why written alpha methoxy propionaldehyde. Okay, now let's see. Third one is this compound. So here valiraldehyde, with this name valiraldehyde is based on the Latin word. So that is used, that is based on their day-to-day life. In the Latin word, it's called valiraldehyde. So that is here. So that's why its name is valiraldehyde. That you will have to mugged up only. And here pentanol, why? Because it's aldehyde, and the main chain is of 5 carbon. So that's why pentanol. Now let's see this compound here. Directly you can solve here. So this is CHO. So this is 1, 2, 3. Second carbon is unsaturated. So that's why we will write here main chain is of 3 carbon. So that's why propane. Or here double bond is also. So we write prop. And at second position there is unsaturation. So we write En only. Because ul we will have to write for this carbon. So 2 null will be there. En only. Okay. Now let's see about this compound next. Two CHO is bonded to the benzene. So in this case here for that one we will use the carbonyl. Okay. Benzaldehyde we cannot say, because if in the benzene only one CHO will be bonded, then we call it the benzaldehyde. But there is 2 CHO group bonded to the benzene. So that's why we will have to write the word carbonyl. So firstly give the position to that carbon. Firstly give position here. So in the position here, this either 1, 2 or 1, 2. Doesn't matter here. So to the benzene, the 2 carbonyl is at first position and at second position. In benzene, there is 2 carbonyl. One is at first position and another one is second position. So that's why we will write benzene 1,2 dicarbonyl. So written benzene 1,2 dicarbonyl. And phthaldehyde, that is here same based on the Latin word. Watch out this compound here. So it is benzaldehyde, you can also write to this compound, because in this compound there is only one CHO. So that's why you can use the word benzaldehyde. And how to write? So this will be the first carbon here. 2, 3, 4, 5. From when you will do the numbering from anti-clockwise direction, then the bromine will acquire 5th position. And when you do the numbering in clockwise direction, then the benzene will get 3rd position. So that's why we do the numbering of this compound in clockwise direction. So if in the cyclic compound, you can do the numbering in clockwise direction or in anti-clockwise direction. So in that case, in which direction you will get lowest position to the substituent, in that direction you will have to do numbering. So here is 1, 2, 3. So it is at 3rd position there is bromo, that is 3 bromo benzaldehyde or 3 bromo benzene carbonyl. Its IPAC name will be maybe. Okay, who is preparing for the NEET, CUT and main examination? That's keep in the mind the another way of writing the IPAC name, because you will have to click there in the option. Maybe what the name you will write, and you practice and not consider the other one, then maybe you get confused in the examination. So what's the other way of writing the compound, that you will have to also consider. So here is 3rd, so that will be IPAC name will be 3 bromo benzene carbonyl. That will be, or 3 bromo benzaldehyde. What you write? And but when you will have to write the common name, in the common name you will have to consider about ortho, meta and para. So it is, this carbon is ortho, this one is meta, this one is ortho, this is meta, this is para. Here also addition to this carbon is this one, so ortho, this carbon is ortho, this carbon is meta and this carbon is para. So bromine is at meta position. So that's why we write meta bromo benzaldehyde. So meta bromo benzaldehyde, that's why written. In this compound here, maybe you get confused that it's ether or ketone. Few students may get confusion that this one is how to predict that it's ketone or the ether. Then I have told you to consider about the tetravalency. So let's see how to draw. So here is CH3 and here is C. If you will write oxygen here and CH2CH3, in that case the tetravalency of this carbon not maintained. only 2 valency get completed. So that means this oxygen is not along with this chain. That means this oxygen is not doing bond formation with this carbon, this alkyl group directly. So how to write? Then after consider about the tetravalency. Then after, by considering the tetravalency, then after it will be CH3. So keep this oxygen to this carbon. So here double bond. Now the tetravalency of this carbon is completed. From the molecules directly also you can watch out. Yeah. So the here valency suddenly shift. This oxygen if there will. So only one valency, only 2 valency of this carbon will get satisfied. If you will keep this oxygen along with this alkyl group, then only 2 valency of this carbon will get satisfied. So that means this oxygen is not in this chain. That will be different here. So that's why that oxygen is bonded to this oxygen is bonded to this carbon through double bond, and to that carbon this alkyl group will be bonded. So that is here. Now write the IUPAC name 1, 2. You have to give lower position to this the carbonyl group. So here like that here. So main is pentanone and it is at second position. So pentane 2-one, that's written pentane 2-one. And for this common name, you will have to write the 2 alkyl group during the writing the common name. In case of ketone, we write the name of the alkyl group bonded to the acylic carbon, and that will be according to their alphabetical order. So what is here? This is here methyl. So firstly comes methyl M, firstly comes M, and then after P, it's methyl, and it's propyl. So M comes first in compared to P. So that's why we will write methyl, and it is propyl. So we will write here methyl, and it is normal propane. It is not secondary. Here there is chances. In case of propane, there is chances that there will be normal propyl or the isopropyl. So here it's normal propyl. So that's why we will write methyl, then after N propyl and ketone. In case of ketone, the IUPAC name will be on. That is here suffix we will use on. And when we will have to write the common name, then we will have to write the name of the alkyl group bonded to the acylic carbon atom according to their alphabetical order. And then after use the word ketone. In case of IUPAC nomenclature, only on. And in case of common nomenclature, ketone. So that's why its common name is methyl normal propane, methyl normal propyl ketone. Let's see about the next question here. This molecule. So here is 2-methyl group is bonded to this CH. So here CH stick and 2-methyl group bond here. Then after is C double bond O. So here C double bond O. Why here again? Because if C double bond O, if you will keep this one, then if you will bond this oxygen with this carbon, then the tetravalency of this carbon will not get satisfied. So it's not ether. But if there be CH2, then that would be the ether. Okay? If there be CH2 and then after Cu, then after this one, then that will be the ether. But there is not CH2. Then here is not CH2. That's why that to maintain the tetravalency, this oxygen will do double bond formation to this carbon atom. And then after defining a structure, so this acylic carbon is bonded to this CH. So here CH, and this CH is bonded to 2-methyl group. So 1-methyl group here, another methyl group here. Then after write the IUPAC name. So what happened here? So functional group is this one. You have to give lowest position to this functional group. So when you do the numbering from right to left, this is also methyl and this is also methyl. So you go from this direction or from this direction. You go in this direction directly or in this direction. Doesn't matter here. So that will be 1, 2, 3, 4, 5. So the acylic carbon will get third position. And when you will do the numbering from right to left to right, so here also the acylic carbon will get third position. So same position from both sides you get. So do whatever in any manner you do the numbering, you will get same IPAC name. So how to write the IPAC name here? So it is main chain is this one. So 1, 2, 3, 4, 5. This one. So methyl group is at second position and at fourth position. So that's why we'll write 2,4 dimethyl. So that will be written, compound will be 2,4 dimethyl, and it is of 5 carbon chain. So and with which the ketonic group is at third position. So pentane 3-one. And how to write the common nomenclature? So common nomenclature, watch out here. This alkyl group is and this alkyl group is same, and it is isopropyl. That means there is 2 isopropyl. That means in this compound there is 2 isopropyl group bonded to the acylic carbon. So that's why we will write diisopropyl ketone. Okay, diisopropyl ketone. And IPAC name, you may check that. What's the IPAC name I have written? That's to check. Now last one here, in this case here, how to write the IPAC name? So this is ketonic group. So first position, second position. So first position, second position. So 2-methyl cyclohexane, 2-methyl cyclohexanone. So 2-methyl cyclohexanone here. In this compound here, draw the structure. Yes, carbon and 2-methyl group is bonded to this carbon. So here carbon. Watch out this compound. That means here there is 2-methyl group bonded to this carbon. So here carbon and 2-methyl group. And that is doing double bond formation here. Then after CH, so here CH. Then after C double bond O. Because here not CH2 here. And if you will include this oxygen in the main chain, so that will be catatovalency of the carbon will not get completed. So that's why that means this oxygen is doing double bond formation with this carbon. So here now watch out, this is ketonic group. So here you must have to include this carbon in the main chain and these 2 carbon. Now you will have to do the numbering in such a way that the ketonic group will acquire. You will have to do numbering in such a way that the ketonic group will acquire lowest position. So that will be is possible when you will do numbering from right to left. Here is methyl. So it at fourth position there is methyl. Main chain is of 5 carbon. So pentane. So pent here because double bond is also written. So pent, and here it is 3 in and 2 on. Because unsaturation is doubly bonded carbon atom. That means unsaturated carbon is at third position and the ketonic group is at second position. That's why written pent 3 in 2 on. And common name is mesithyl oxide. Common name is mesithyl oxide, this which is based on the Latin word. Okay. Then after let's see about the structure of carbonyl group. Watch out here such a drawn. So watch out here the hybridization of this carbon is what? sp2. How's? Because this carbon is forming 3 sigma bonding, one with hydrogen, one with the carbon of alkyl group, and 1 sigma bonding with oxygen. Okay, so this carbon is forming 3 sigma bond. That's why this carbon need only 3 hybrid orbital, out of which one here, since this carbon is forming 3 sigma bond, that's why this carbon require 3 hybrid orbital, and to form 3 hybrid orbital, the 3 atomic orbital will merge together. So one atomic orbital will be of S and the remaining 2 will be of P. So that's why its hybridization will be sp2. So hybridization of this carbon is sp2. Now watch out about the oxygen. There is 6 valence electron oxygen has. Oxygen has 6 valence electron, of which it has involved its 2 electron in the bond formation with the acylic carbon. So remaining 4 non-bonded, remaining 4 non-bonded. That means there will be 2 lone pair of electron this oxygen will have. So there will be 2 lone pair of electron. The hybrid orbital either do sigma bond formation or contain the lone pair of electron. The hybrid orbital either do sigma bond formation or contain the lone pair of electron. So this oxygen needs also 3 hybrid orbital. 3 hybrid orbital, so 1 atomic orbital. So 3 hybrid orbital here. So to form the 3 hybrid orbital, the 3 atomic orbital of oxygen will merge together. So of which 1 atomic orbital will be of S and the remaining 2 atomic orbital will be of P. So hybridization here of this oxygen will be sp2. So in acylic group here, the hybridization of acylic carbon atom as well as of oxygen atom is sp2. The carbon atom, one sp2 hybridized orbital will do sigma bond formation with the carbon of the other alkyl group or with the 1s orbital of the hydrogen. In case of aldehyde, one sp2 hybridized carbon atom of one sp2 hybridized orbital of carbon atom will do head-on overlapping with the 1s orbital of hydrogen. In case of aldehyde, here either the sp2 hybridized orbital of the carbon or with the 1s orbital of the hydrogen, and it's so 2 hybrid orbital, 1 hybrid orbital it will do head-on overlapping with the sp2 hybridized orbital of oxygen. So this carbon will have 1 unhybridized p orbital. This oxygen will have also 1 unhybridized p orbital. There will be sidewise overlapping between the unhybridized p orbital of the oxygen, and there will be formation of pi bond, and this oxygen will contain a lone pair of electron in the sp2 hybridized orbital and other lone pair of electron in other sp2 hybridized orbital. There is so many, watch out here when the merging of the two dumbbell here. So extent of overlapping will be like that of a banana. There is. So that means here, that's why this type of pi bonding is showing like this here. So extent of overlapping is that much. There means remaining portion will be unhybridized. Like this portion and this portion will merge together. So that's why when merging will be there, so this type of shape will appear. Here, now consider about this carbon. Then this carbon is forming sigma bonding with this oxygen. One sp2 hybridized orbital of this carbon atom is head-on overlapped with the sp2 hybridized orbital of this oxygen, and there is formation of sigma bond. Same one sp2 hybridized orbital of this carbon that will be bonded to that will be merged with the 1s orbital of the hydrogen or with the hybridized orbital of the carbon. Same here, this bonding same also here, that will either do head-on overlapping with the 1s orbital of hydrogen or with the hybridized orbital of carbon. The unhybridized p orbital of this carbon and that of this oxygen, that will do sidewise overlapping and there will be formation of pi bond. So when extent of overlapping you will watch, then this shape, in this shape there will be. So above portion will merge and below portion will merge, and there will be a number of portions of this one unhybridized p orbital and that of the unhybridized p orbital which will not merge. So the merged portion has been shown by like this. Whenever the hybridization will be sp2 and the central atom will not contain the lone pair of electron, then the shape of molecule will be trigonal planar. So trigonal planar, so that's why here this one here is of carbon or hydrogen. Here this one is the bond of with carbon and hydrogen, and here is oxygen. So here is at the carbon atom there is no lone pair of electron. At this carbon there is no lone pair of electron. So shape will be trigonal planar. That means bond angle will be 360 upon 3. That will be 120 degree. So bond angle will be here 120 degree. Main portion here is what's the hybridization of the acylic carbon atom of the oxygen atom, and what be the bond angle around the acylic carbon in case of aldehyde and the ketone. Now how the reaction takes place? How the reactions takes place, about that, okay, we will discuss later on here in the chemical properties directly. Now let's see this compound here. One question I am here, these questions right now I have discussed. This one very simple. So firstly you will have to draw butanol, that means of 4 carbon, 1 2 3 4. Third position OH, because third position hydroxy, and butanol, so here double bond and here H. Remaining you balance, give their number of hydrogen by considering the tetrahedral, by considering the tetravalency of carbon. Now let's see this question I am drawing. Okay, cyclopentane carbonaldehyde, firstly draw cyclopentane. So this one, so firstly draw cyclopentane and carbonaldehyde, that means CHO here, any place, either here or here or here, wherever you would like. And at second position there is hydroxy. So this is first carbon, this is second carbon, and so here you may add OH, or you may also consider this carbon as second carbon. So in that case OH will be there. 4 oxopentanol, so that is of 5 carbon, 1 2 3 4 5, and 4 oxo, so 1 2 3 4, so here double bond, and pentanol means here double bond O and here H. Then after remaining here, balance them according to their tetravalency. Fifth one, also watch out, disecondary butyl ketone, it's the common name. Disecondary butyl ketone is the common name. So common name here, that means it's indicate that the compound is a ketone. So ketone here, so C double bond O, and here both sides there will be secondary butyl. So secondary butyl will means what? Here it's the butane. So of this butane, the secondary carbon atom will be bonded. That means one hydrogen will remove from there and the secondary carbon will get bonded to the main chain. Then that will be called secondary butyl. So this side if you draw the secondary butyl, and this side also. So it is disecondary butyl ketone. This one you draw by yourself. Okay, as much I have drawn, you draw for at least one question. Okay, so then after is, that was about the nomenclature, IPAC nomenclature, and in some cases common nomenclature. So that was here. In the next class we will discuss about the method of preparation of aldehyde and ketone. In the preparation of aldehyde and ketone, there will be some common method for the preparation of both aldehyde and ketone. That means there will be some method by which you can prepare aldehyde as well as ketone both. There will be some reaction which you can use to prepare the aldehyde, and some reactions there will be by which you can prepare only ketone but not aldehyde. About those reactions or method of preparations we will discuss in the next class. It's all for this class. Thank you, Team Educate.